everyone. Good morning. Hope you're enjoying the talk so far. Our next talk is Simon Aubury, who's here to talk to us about DuckDB. Please welcome him to the stage.
Thank you, Jay, and thank you everyone who's come along today. Today, we're here to talk about one of my favorite subjects, DuckDB. Now, unfortunately, my co-presenter, Ned Letcher, can't make it and join me here today. But although there's one person on stage, I'd like you to just remember there's two people who've contributed to this slide deck today. So I'm going to do my best to share his amazing content as well. So today, we're talking about wrangling data with Python and DuckDB. And I have a hope. I have a hope that today you're going to leave with an appreciation about what DuckDB is. And I hope you appreciate that DuckDB can be an invaluable tool for anyone working with analytical data and analytical data with Python. So I'm going to start with something pretty grounding here. What is DuckDB? So here is how the DuckDB project describes themselves. DuckDB is an analytical, in-process, SQL database management system. So that's how the project describes itself. But I did want to take a few moments just to unpack that so we can come essentially from a shared understanding. So what does it mean when we're talking about DuckDB being an analytical database? Well, we're going to have to start off with this understanding that not one database can handle all types of workloads. And DuckDB is optimized for analytical workloads. That's analytics over large data sets. So that's things like needing to derive aggregate summary statistics, like averages and sums. And typically, those are things that are sort of grouped together around some sort of dimension. So these are the queries that are sort of columnar-orientated. And DuckDB is designed and is really in the sweet spot of working on those sort of columnar-style operations with blazing speed. And it's also worth understanding that when we're talking about this, we're talking about data that's sort of quite large and can exceed the size of the memory available to you. So we need to contrast that against transactional databases. These are kind of data systems that are orientated around row-based operations. These are kind of designed for workloads that involve sort of high throughput but record-based reads and writes, like web applications or clickstream analytics. So DuckDB is the former. That allows us to process larger data sets than are available from the memory of your laptop without the need to spin up a distributed compute cluster. And DuckDB is crazy fast. I'm hoping that you're going to get a bit of a sense around the size and scale that we're going to talk about today. So what does it mean when I'm talking about in-process? Well, we're talking about that's something that's sitting in the same application process space as your Python application. So in-process means running your application not as an external process, but actually within the same process space. There's no client, there's no server, there's no network. We're actually talking about a SQL engine that is the library within your application, and it's part of your application context. This makes DuckDB incredibly simple to drop into both your applications and your workflow. And this means that DuckDB is sort of an analogous to something like SQLite, but for analytical workloads. So this makes life much easier because you're not dealing with a client-server architecture. You've just got essentially a pip install to give you this powerhouse. And we're also talking about SQL. So DuckDB's primary interface is SQL, or Structured Query Language. So if you've not come across it before, SQL is a powerful and widely used programming language for managing and querying data stored in relational databases. So DuckDB is using essentially its slightly tweaked own SQL dialect, but it's very, very similar to PostgreSQL. It also offers a range of sort of ergonomic enhancements over and above basic SQL. There's a couple of sort of niceties that the DuckDB folk have actually put into their open source project. For example, trailing commas within your column list will not freak out the syntax, and it's those little niceties that make working with DuckDB an absolute delight. For Python folk, you'll really appreciate the list comprehension that's been built into the list aggregator. And again, it really smooths out some of the rough edges of dealing with SQL. Now, you don't actually have to use SQL, and later on we're going to be talking about some of the ways that you can use DuckDB without having to use the SQL interface. Finally, DuckDB is more than just an extension of a data processing framework such as Pandas and Polars. It's actually a complete database management system. So you get things like query optimization, data catalog, stored procedures, transactional consistencies. So these are kind of like the characteristics that you get from a data processing system such as a database. That means that you've got a bunch of features at your disposal which really helps you with your workflow. And maybe from a situational perspective, that helps folks like data scientists who want to do analytical workflows, such as working with pipelines or analysis, working with curated data sets. If you're building data applications and you want to have like a backing store for your Streamlit application or your Dash application, DuckDB really helps with that. And it ultimately positions your data processing on your laptop, much like you've got access to your own data warehouse. So DuckDB is actually quite powerful because it gives you essentially a database management system at your disposal. So that's become a bit of a definition and hopefully a grounding thing, but you're probably curious about what this actually looks like in the real world. So I wanted to run through a few examples here of how you actually do analysis using DuckDB. And I'm going to use the Melbourne bike share station reading data just to sort of illustrate what working with DuckDB looks like. And before I get onto DuckDB, I'm going to do this as a sort of a positioning exercise of how you do this with pandas. Now, many folks will have come across pandas, but just to sort of orientate folk, pandas is a common framework for dealing with data sets. And if we were bringing up our Melbourne bike share data, and we actually had a local file called the Melbourne bike share CSV file, this is probably some code that would typically write to load it. We'd call the read CSV function with a number of configuration options, and would probably be describing the columns we wanted to lift out of that CSV file: ID, name, run date, latitude, longitude. We'd probably need to actually describe how to parse some of the data types here. So there's a run date column. We'd probably need to hint the actual format of that date time column and make sure that we can actually lift that into the data frame correctly. So if we run that in pandas, this is probably some non-surprising stuff. We'll get a fully loaded data frame back again. And this particular data set, it's got about 5.6 million records. And when Ned ran it on his laptop, this processing took around 9 seconds or so. So let's contrast this experience with how we'd be doing this same kind of data analysis loop with DuckDB. So firstly, there's a couple of differences here. The first thing I'm going to do is import DuckDB. And I'm going to be using DuckDB's SQL method and actually start off this processing using a bit of SQL. So a lot of the goals are exactly the same. I'm going to be describing the columns I want from that underlying file by putting that into the select part of my select statement. So I'm picking out the columns I want. Within the from clause, I'm going to be using DuckDB's read CSV function, and I'm going to be pointing it to that underlying file. And I'm going to be passing on some similar configuration, much like I used in pandas, to describe how to actually parse that datetime format. Now, the important thing to note here is what's different. The result of this query actually hasn't happened yet. This is actually a delayed action. So what DuckDB is going to give us at this point is what's known as a relationship. That's the REL variable there. This is lazily evaluated query. So nothing happens until I do something with that rel function. So this is going to happen instantly, but the moment I do something with that rel function, that lazy evaluation will happen on my behalf. So the moment I do something like display the rel variable, DuckDB is going to interpret that and work out the minimum amount of work that's necessary on that lazy evaluation path. In this particular case, we've asked to display the relationship. And this is what actually happens. Note that we've not brought back the 5.6 million rows. We've just brought back about 10,000 records or so. And it's given us a quick sample. And this allows us to sort of inspect the data for correctness And it also did it really quickly. This took about 0.2 seconds. But this is helpful for someone in that sort of feedback loop. I didn't want to wait 10 seconds. I just wanted to glance at 10,000 records. And so that relationship function has actually helped me on that way. The relationship object is part of DuckDB's API for Python, and we're going to come back to what that actually means. So let's carry on with a bit of exploration, and now we're going to use that relationship object to do some data processing. So imagine that we're in this situation where we actually wanted to do something like work out, I don't know, the average number of rentals during 2017 and break it down by month. So we would write a bit of a SQL function here. So would be extracting the run date, would be sort of targeting it for the year 2017. We would be grouping it by month and ordering it by month. And what's important to note here is that when we're running this, this lazy evaluation through the relationship function is actually waking up, and it brings back the answer at record pace, because we've only needed to evaluate some bits of that query, and we've only needed to pull back some records from the underlying table. So this makes this result set come back really, really quickly. Again, this took 0.1 of a second to actually parse over that same file and pull out just the relevant data to solve this question. So if we compare that result with trying to do it in an equivalent way in Pandas, there's a couple of differences to note. Firstly, it was much faster. But from my perspective, this is actually much more elegant because we're actually being much more descriptive in what we wanted to achieve rather than how we wanted to achieve it. Pandas is much more specific with pull out the columns, do the filter, do the aggregate, do the rounding. Whereas when I'm working with SQL, I'm just describing the how, the why rather than the how. And I think that makes it sort of cleaner and easier to read. We just describe essentially the outcome that we want. So many folks will be sitting there and going, well, that's good, but we typically want to talk about this in the broader context of a pipeline. So let's talk about how DuckDB can help you with that sort of next stage of the processing pipeline and talk about how easy it is to start exporting the data. So quite often we're in a situation where we wanted to run a query and then maybe send it off to a CSV file or a Parquet file or a JSON file. Now, DuckDB just does this out of the box by using the copy into command. And there's a lot of simplicity that's probably happening here, but it's worth spelling out. I can target a CSV file by just saying .csv file. If my intent is to write to a Parquet file, I just need to put .parquet at the end. Equally, if my goal is to write some JSON, I just say copy it into .json. DuckDB is taking care of a lot of the boilerplate code to actually worry about the ask around encoding that. Now, out of the box works simply, but sometimes we actually want to do some overrides here. So if I want to change the configuration options, I can actually do things like change it to be new line orientated for JSON. I can change the delimiter. And the observation here is that DuckDB gives us the ability to wrangle data in a simple way. And when I need to drop down and actually step past some of those sensible defaults, I've got all of the controls there available to me. So that's sort of exporting the results of our data set. But we probably want to take a further step out and actually see how DuckDB sits in that sort of broader Python ecosystem. And one of the really amazing things about DuckDB is that DuckDB sits and plays alongside other Python data structures. So we can readily export to things like pandas, polars, arrows, numpy, by just essentially taking those relationships and expressing how we actually want to generate those data frames. We can do the converse, which is also really cool. If we have a data frame, we can actually run SQL directly against it. And that, to me, is a bit of a superpower here. We're running SQL directly on top of data frames, no matter how they were formed in the first place. So this ability to run queries against data frames is a true superpower of SQL, of DuckDB, and the ability to wrap it all up with SQL makes it quite simple. Now, many folks will then be thinking about, this is cool, but maybe I don't actually want to use SQL. So DuckDB's actually got you covered there as well. DuckDB has this relational API, which we've already explored briefly, but it's worth stressing that it's an alternate way of actually using those same processing engines under the covers. It's built into the DuckDB client, and it's also super convenient. But it doesn't have the full sort of ergonomics of working with a data frame. So DuckDB also supports Ibis. Now, Ibis is designed to provide like that ergonomic data frame experience, and it compiles queries down to SQL on your behalf. And it targets a wide range of SQL dialects, inclusive of DuckDB. And this means that your queries are both highly portable across back-end databases, and again, it means that working with Ibis means that you're working across many different data engines, inclusive of DuckDB. So that's sort of good in concept, but you probably want to see some code behind it. So let's compare a query that's been sort of expressed for the relational API. And imagine that we had the goal of just seeing the total number of bike readings for all of 2017. So we can apply a filter here using that filter syntax. And that filter query is pushing down into the relational API, and it's equivalent to that expressive SQL syntax. So we can do the same in Ibis, and the takeaway here is that it's essentially a different level of verbosity when we're dealing with some of those sort of relational frameworks versus data frames. So there's a bit of a recommendation here, is that it's worthwhile using the relational API when it's convenient, and when you want that sort of data frame experience, dropping down to Ibis is a bit more of a familiar territory. And what I really appreciate with DuckDB is it's not opinionated. You can actually use both, and you can also interleave these things, and you've got the power of the framework under the covers. So those are lots of building blocks. So let's take an even broader view of how DuckDB can sit in front of a sort of a bigger ecosystem, and actually talk about how we can actually work through some real-life problems. And one of the things I kind of work with in my day job is just an appreciation that data can sit across many different areas, and we have to work with local data, and that could be local Parquet files, or Excel files, or JSON files. Sometimes I need to deal with data that's maybe in the cloud, maybe it's presented through an API, maybe it's on top of an object store, maybe it's in an open table format. And sometimes I need to deal with data that's maybe hosted in another external relationship RDBMS, such as Postgres or MySQL. One of the things I really appreciate about DuckDB is it allows you to interconnect to all of these systems and actually help deal with data no matter where it's resident. And just to sort of make that a bit more obvious, I've had some situations where DuckDB has actually helped me work through a number of paper cuts when I've just been trying to do daily sort of data processing. I wear a Fitbit. I'm quite curious around some of the data that's being captured. So a couple of months ago, I downloaded my Fitbit archive. Turns out when I did that, I downloaded 72,000 JSON files. And I wanted to sort of quickly bring that into DuckDB so I could just do some data analysis. One of the things I really appreciated was it was straightforward going read JSON, here's a glob for all my JSON files, and it even worked through the rather esoteric arrangement of timestamp formats within those JSON files. And the fact that I could do like this fairly clunky data processing with a one-liner was something I really appreciated. Equally, there's many ways to process Parquet files, but I love the ability for DuckDB to sort of wrap some of those edge cases, like dealing with things like encrypted Parquet files. There's a built-in secrets manager into DuckDB, so if you've got the need to deal with things like encrypted things, it's got you covered. Equally, if you've got data maybe resident in something like a Microsoft Excel file, DuckDB can just read off those binary files, and all you have to do is tell it which sheet to pull from. Those are just a couple of examples that I've come across, but the takeaway here is that DuckDB is quite capable of working across various formats. It's also an extraordinarily extensible data processing framework. These extensions are growing and being added to by the community all the time. So I love the fact that we can hit up data resident in things like public cloud providers, open table formats, but the ability to also work with things like geospatial extensions and being able to interact with other database management systems is really, really a powerful superpower when working with DuckDB. The other thing that's kind of cool about working with data through DuckDB is just the flexibility around locations of where you're going to work with data. For example, if you've got files and they're sitting on an object store, such as MinIO or Azure Blob Store or AWS S3, you can point DuckDB directly to that S3-compatible endpoint, and it would just be able to bring up the file as if it was local. Equally, if you've got data resident on an HTTP, or presented through an HTTP endpoint, again, you can just use a read Parquet reader directly against a URL, and it will pull the data through. And another cool party trick is being able to hit up a RESTful API. If it's presenting data via RESTful API, again, you can just query it directly. And this works for both public endpoints, but also works for private endpoints. You can provide things like bearer tokens or S3 credentials if you've actually got hidden data. So it's also worth pointing out that this is somewhat smarter than it looks. Under the covers here, DuckDB is actually doing a lot of heavy lifting from the data processing side. So if I've got a fairly innocuous statement like this, where I wanted to query some data off S3, it will do the job, but it will do the job quite effectively. For example, if I wanted to pull out maybe the first column and the 12th column of a query of a Parquet file, DuckDB is smart enough to only do range scans across the network, so it's only going to bring back the necessary data. If the Parquet file is actually being encoded with a zone map, it will be smart enough to use that to, again, skip unnecessary reads. And if the files have been put on top of a Hive partitioning, unnecessary files aren't pulled back. The takeaway here is that even though the syntax is easy, it actually does a lot of sort of smart processing on your behalf, thereby making it faster. Alrighty, so we've taken you through some of the building blocks, but what I would like to do is sort of wrap all of this up with more of a practical example and hopefully give you a bit of a sense and a bit of encouragement of here's some of the problem spaces that DuckDB and Python solve neatly together. Now, I'm actually a visitor to Melbourne, and I understand that one of the important things to do in Melbourne is to go get yourself a really good cup of coffee. So I'm going to use DuckDB to help me with my mission to actually find a local coffee place that I can enjoy after PyCon finishes today. So one of the first things I wanted to do was hit up an open data set, and the lovely city of Melbourne publishes cafes, restaurants, and bistros just as an open API. So I can write myself a bit of Python code, which is actually going to go and create myself a local table by just hitting up that public data set. And there's a lot going on here that I probably should just point out. I can create a table automatically by just saying create table as select against that endpoint. And there's a lot of things I didn't need to do here. I didn't need to describe the columns. I didn't need to describe the data types. I didn't need to move the data in locally. This one statement has done all of that on my behalf. And if you're curious, it's bringing out the data types by essentially sniffing the first 2,000 rows of the table and making some smart inferences around what the schema actually looks like under the covers. The other thing I'm going to do here is, because I want to do this several times over, I'm going to get DuckDB to create myself what's known as a persistent database, where essentially it's saving the result set to disk as opposed to in memory, so I can do further processing later. And this one bit of SQL, hopefully that sort of is self-explanatory. It's a create table as select, and it's actually using that cafe source URL to actually source the data. So that goes and creates my table. And now I probably want to do something useful with it. Now, I don't want to walk too far to find my cafe, so I want to do just a bit of a geospatial bounding box, and I'm going to use geojson.io, which is a great online tool for just building little boundary boxes. So I'm just going to do a boundary box of the cafes that I'm interested in. Now, because I'm working with geospatial data and I've got a data set, I now actually want to use these two things together. So I'm going to bring in the geospatial extension. So I'm going to do these couple of steps to install the spatial extension, and that makes DuckDB geospatial aware. So I can now do this kind of thing, which is essentially a predicate that's going to filter just points, latitude and longitude points, which are within that boundary box, which I had loaded from that boundary region.geojson file. So there's a few bits going on here, but the takeaway here is that I'm going to be creating a database view, which is just going to pull out only the cafes, restaurants, and establishments where the latitude and longitude are within that boundary box. And again, this means that I've done this essentially with one command and one tool, and I've done it all within Python, and I'm getting a lot of those sort of extra frameworks and efficiencies automatically inherited as part of DuckDB. So that gave me a relationship, and obviously I want to do something with that relationship. So now I'm going to start thinking about, well, what's that sort of iterative loop that I wanted to go through here? So I'm going to be specifically looking for a cafe, so I'm going to apply a filter called I only want cafes and restaurants. I decide that it's too hot outside, so I want to be inside, so I can apply a filter to limit my cafe selection to purely indoor areas. And I'd prefer like a smaller establishment rather than a big place, so I'm going to order by the number of seats advertised. And bear in mind that this is already pre-filtered against cafes within the boundary box. So this is going to help me narrow down the perfect number of cafes. And I'm just going to say, well, just bring me the first 10 out, and hopefully that's going to solve nearby cafes that are indoor and that have a sort of a small sort of intimate feel to it. And this is what that query looked like a couple of days ago. So I'm hoping that the locals in the room will be able to tell me if any of those actually happen to be a good cafe. So we've taken you through quite a lot here, but I kind of just wanted to wrap it all up and just give you a bit of a sort of a bit of a sense around what we've gone through, and also a quick call to action around why DuckDB is something that you should be considering within your Python analysis toolkit. So DuckDB and Python, they come together really nicely. We've seen DuckDB is versatile. We can work with various data types, and we can work with all sorts of data locations. It's powerful. It's working at great scale. It's working with great speed. And it uses every bit of thread and memory and pipeline optimization that is available in that rapidly evolving high-speed data processing ecosystem. It's crazy powerful what you can actually process on your own local laptop. We've also shown that DuckDB is interoperable. It's interoperable across data frames. It works in memory. It works in process. And it can even work in your browser in a WASM runtime framework. It's crazy interoperable. And I'd also like to leave you with this mindset that it's frictionless. It was but a pip install. It is but one more thing to add to a well-regarded framework. And I just love the fact that at the end of the day, DuckDB helps me with my day job by being these things: versatile, powerful, interoperable, and frictionless. Now, I'm hoping that this has given you a bit of a sense around both what DuckDB is and how useful it is. And I kind of wanted to leave you with two takeaways. Firstly, all of the examples that you've seen here today and the slides today are available at this via Ned's repo. This QR code will take you to that repo. And if this has sort of whetted your appetite and you want to learn more, Ned and I are both very, very passionate about DuckDB, and we authored a book together. So if this has got you interested, and this has only sort of scratched the top 2% of DuckDB, if you want to follow along with the rest of it, there's some great resources out there, and I'd hope you would consider our book as one of those resources. And with that, I just wanted to say thank you very much, and enjoy the rest of PyCon.